Welcome back, guys. In this last part of this chapter, we're going to talk about the general plane motion in kinetics for a rigid body. In the previous chapter, we talked about the general plane motion kinematics, and we said that a general plane motion means that I have a translational motion as well as a rotational motion. And in this case, we applied the relative motion analysis to find the velocity as well as the acceleration. Now here, guys, in kinetics, we have to find the three equations that are the sum of forces in both directions if I have a plane motion, as well as the sum of moment in order to find the three unknowns in this general plane motion for rigid bodies. So what are these forces? In fact, since I have translation, then the sum of F in x direction will be equal to magx. Now, if I have also a translation in y direction, then this sum of forces will be equal to magy. Usually, we're going to have a translation in one direction, either in x or in y or in a direction, let's say like s. So I can take the sum of forces in this direction, then the sum of forces in the direction that is perpendicular to this direction where translation occurs, in this direction, I'm going to have that the sum of forces will be equal to 0. So if I have here, for example, a translation in x direction, then I'm going to have sum of x is equal to magx in x direction, and sum of fy will be equal to 0. The third equation will be, of course, about rotation, because in fact here I have a general plane motion, which means translation plus rotation. The translation is represented using these two equations, while the rotation will be represented using the sum of moment around the center of mass is equal to Ig alpha. And as I said in the pure rotation, I can also say that the sum of moment around a point O is equal to the sum of moment of all the resultant forces around this point. Now, if I want to take the case of frictional rolling problems. Now, if in the previous chapter we talked about the rolling problems, but we concentrated or we focused on the case of acceleration and velocity. And we didn't know the causes behind this change in acceleration or velocity. Now here, we have to focus on the frictional force and on the forces causing this with the slipping or without slipping frictional rolling problems. So guys, in order to do this, let's take this example. So in this example, I have a rolling motion. I have a wheel doing a rolling motion, all right? It could be cylinder, it could be disc. And I don't know if this body rolls without slipping or if it is sliding in this direction, in the horizontal direction as it rolls. So I want to find out the equations for slipping and non-slipping case, and I'm gonna know what is my case. What are the conditions to say that there is no slipping in this problem? Now, what are the forces exerted on this disk? I'm going to have the towing force or the force that causes this rolling motion. Let's say it's P. I'm going to have a frictional force, which is, of course, opposite to the motion. I'm going to have the normal force from this horizontal contact. And, of course, I'm going to have the weight of this wheel or of this cylinder. Now, if I want to apply the equations of a general plane motion, I have sum of x equal to magx, sum of y is equal to magy, and the sum of moments will be equal to Ig alpha because I have a rotation. Now, what is the sum of forces what are the forces in x direction? I only have F here, and it's in the negative direction plus P here, right? Which means P minus F is equal to magx, which is the acceleration of the center of mass in x direction. But I know, guys, that the acceleration of the center of mass is only in x direction. So I don't have any acceleration in y direction because I don't have any motion in y direction. And that's why I can replace agx by ag. Now what about the sum of forces in y direction? I have minus the weight, and I have plus the normal force. So n minus weight is equal to what? It's equal to 0 because I don't have a y. Alright? Now, if I want to apply the sum of moments is equal to Ig alpha, what are the forces that cause a moment around the center of mass, I know that the weight and this force P, they are passing through this center of mass as well as the normal force, all right? So the direction or the line of direction of this normal force is passing through this G, so they do not have any moment around G. The only force that has a moment around G is the frictional force here. And the distance between the frictional force F and the center of mass is the radius of this disk or of this cylinder, which means Fr is equal to Ig alpha. Now, let's discover what are the unknowns in this equation. I should know P, all right? I should know P because I should know the force causing this rolling motion. Let's say I know P. I don't know the frictional force, so this is my first unknown. I don't know the acceleration, Eg, so this is my second unknown. I don't know the normal force, so this is my third unknown. I know, of course, the weight, and I don't know alpha, and this will be the fourth unknown. All right? So I don't know N, F, A, G, and alpha, which means I need a condition, a simplification, or a fourth equation. So what should I do? In fact, guys, this differs between two cases. If I have a no slipping condition or a slipping condition. If I have a no slipping condition, remember guys from kinematics. Guys, in kinetics, I should use also my knowledge of kinematics. And we did this, if you remember, in the case of particle, right, chapter 12 and chapter 13. We should use kinematics in kinetics, all right? So I know, guys, if I do not have any slipping condition, this means that AG, the acceleration as G is only the tangential acceleration, which means it's only equal to alpha r. AG doesn't have any component in the normal acceleration, and we proved this in the previous chapter. You can go back and check it out. Which means, guys, that AG is equal to alpha times r, and this will be my fourth equation. Guys, do not use this equation. F friction is equal to mu s times n. Why? Because in fact, guys, in this case where no slipping occurs, what does this mean? This means that this disk or this cylinder is not sliding, right? It's not sliding at this point, which means, guys, in this case, the frictional force does not overcome the static friction, right? So I am in the case where there is no slipping, which means this F here does not overcome the static friction, mu s times n. Because if F overcomes this mu s times n, then this means that I'm gonna have a sliding, and I'm gonna have the second case where slipping occurs, and I'm gonna have a kinetic friction force. Alright? So guys, remember, since I don't have sliding, I only have a no slipping rolling, then the friction force will not be equal to mu s times n. It should always be less than mu s times n in this case. Alright? So what you have to do is to take the fourth equation as alpha, Ag is equal to alpha times r, and we don't use F friction is equal to mu s times n, but we have always to verify this assumption by checking if Ff is less than mu s times n. If F is not less than mu s times n, this means that I'm not have a no slipping condition and my assumption is not correct. But guys, if I have a slipping case, which means there is a sliding, you have to use mu k times n, which means I am now in dynamic frictional force. Alright, so you're gonna use Ff is equal to mu k times n as your fourth equation, and then you're gonna have four equations, four unknowns, so that you can solve. Alright? So this is for the frictional rolling problems. Now what are the procedure? What is the procedure for analysis? In this case, in fact, guys, it's the same. So you have to establish your reference, specify the direction of AG, and don't forget, guys, that AG follows alpha. So if alpha is let's say in this direction, then AG will be to the left. If alpha is clockwise, then AG will be to the right, and then if AG is negative, then this means that AG is in the opposite direction, and you have of course you have to find IG or IO, and then you have to find the equations for the general plane motion, sum of x, sum of y, and sum of moments. And then guys, you have to identify your unknowns. If you have a slip or no slip assumption, you guys have to know what you should assume. Now, if you assume no slipping condition, then A will be equal to alpha R, but you have to check the validity of your assumption by checking if the F found is less than mu S times N. Alright guys, if not, you have to take if F is equal to mu K times N, and always F will be opposite to the portion. So guys, this is for chapter 17. It's not complicated. I think it's the combination of statics and kinematics of rigid body. Why I'm saying statics, because in statics we learned how to find the sum of moments. Now here the sum of moments is not equal to 0 except in the case of translational motion. Now here the sum of moments is equal to I times alpha. This is the only difference. Thank you guys, and see you in the solving session.